Equilibrium, the big nothing. I'm just a big nothing. There's a video that my kids would watch, math, and the zero would come in and say, I'm just a big nothing. And that's what we're talking about with equilibrium. When the resultant of all forces acting on a particle is zero, it is in equilibrium. Okay, so if you have only two forces, this actually is really easy to deal with, right? If you have two forces, they must be equal and opposite. So if you have a force up and to the right of, say, 10 pounds, the only way it's not going to move is if you have a force down and to the left of 10 pounds. Now, if you have more than two forces, it's not always as obvious. And so you have to sum up the forces to determine the resultant. And specifically, you have to sum up the forces in x, and they have to be equal to 0. Some of your forces in y must be 0, and some of your forces in z must be 0. If that's the case, right, if all your forces add up to be 0, then it is in equilibrium, and Newton's first law kicks in, which means that there's some of the forces is 0, so nothing happens. Kind of boring. To figure out these problems, we're going to be using a free body diagram. So let's talk about free body diagrams. First, let's talk about space diagrams. What do we have space diagrams? Well, a space diagram is a sketch showing the physical conditions of the problem. This is the problem that you're going to get in the book. You know, that you're going to get a homework assignment, and it's going to look like this, right? So here you have this truck and this load, and there's these two guys pulling on these cables through pulleys to try to lift up this load. Okay, so that's a space diagram. This is showing what's happening. Well, a free body diagram, we're going to choose a quote-unquote significant particle. So we're going to pick something and isolate that and determine, you know, what do we care about? And we're going to look at that particle and show all the forces acting on it. So we're going to look at point A. So you notice we didn't pick this block, we picked point A. At point A, that block is pulling down with a certain amount of force. There's a tension up in this direction with a certain, you know, in a certain direction, certain magnitude, because it's a force vector. There's a tension in this direction, certain magnitude. And these tensions, this is the free body diagram. At point A, you have a force here, and a force here, right? Now, you'll notice that these people over here, you don't have a force turning around and coming back down here. You don't have a force turning around and coming back down here. You cut this portion through here, and everywhere where you cut through something, you replace it with a force that you cut through. And now these free body diagrams, this is what you're going to need this all throughout. You're going to be tempted early on. You'll probably be able to do a lot of these early homework problems without drawing a free body diagram, and then you'll think, hey, that's not that important. And then I promise you, come later in this chapter 4, chapter 5, chapter 6, you're going to get bit by that. Please get in the habit now of doing free body diagrams so that you will be able to use those later on. Okay, let's look at some more examples. Examples 2.4 and examples 2.6 from the book.